start the recording. Welcome to the final session of the 2023 AI Summer. So we're at the end of our fourth week, and I'd like to start by opening the floor for any questions that you've had about this week's lessons or even going further back. So what questions or observations do you have about this week so far or previous weeks?
Jesse, I think an observation I have is just the speed of AI is changing so much. I've heard so many updates from you in this class, and it's realizing we will continue and need to continue to be on top of our game to stay up to speed and to not think, this is what I'm telling myself, not think I've got it. You know, I got to keep working at it. So that's an observation I would have, and even up to this week and learning more.
Yeah. I agree. And one of the things that we'll finish up with is actually how you can keep up to date, or at least keep your finger on the pulse, and how you can continue learning on your on the areas that you're interested in. Great observation, Raymond.
Yeah, just as a small extension of what he was discussing, it's also helped me both in my planning and also in my meeting articulations, where people are trying to figure out why I'm doing certain things now when basically they don't understand how what came before, what's on Coursera right now, and what's going to probably hit tomorrow line up with my plans. And your descriptions have helped me better articulate those during those meetings, so they know there's actually a coherent reason. I won't put my hand down, but as a FYI, me and Dave actually tie in that joke I mentioned the other day.
Excellent. That is great to hear. John.
I agree a lot with like what's been said before, and definitely like the other Jesse involved me in this program. I'm glad I did it. I'm looking more into machine learning research, but really like I kind of underestimated how quickly AI is being developed, and this kind of opened my eyes, and also gave me the resources that I can continue my learning, and also for classes that I TA that I can offer resources to others as well.
Fantastic. Great insight. Other questions or observations? All right. Then let's start with an overview of where we've been. Then we'll go into, and we'll be talking about how you can actually create applications from your work, simple applications, but applications that you can share nonetheless. Then we'll be taking a bit of a break. And when we come back from that break, pretty much at the top of the hour, I'm going to be asking you to share. Well, first of all, I'll be asking you to share projects that you have in mind. So be thinking about that a little bit, and be thinking about that when we take that break at the top of the hour. If you have projects that you can share and talk about, and I was just mentioning to Cam, who's with Vanderbilt technology transfer, but I will mention that talking about this, in this class would very well count as a public disclosure, because we have a wide variety of people here. So if you can, talk about what you're interested in doing with what you've learned in this class. I'd like to hear about the projects that you have. There are two reasons to do this. One, so you can get feedback from folks, and because we'd like to understand. And two, there are 32 undergraduates that are registered for this AI summer, and some of them are watching live, some of them are watching the recordings. So that's a great way, if you're interested in getting students involved in your projects, to proselytize and to recruit students who know this material because they've been in the class with you. And for many of them, this is the second time through this class. Finally, we'll be talking about how to continue your learning, what additional resources we have, what resources you have now at your fingertips that you didn't have before, namely generative AI, because it's a perfectly good idea to use generative AI to learn about generative AI. Excellent. So, broad overview. So at the very beginning of this, which was just a mere 4 weeks ago, we introduced the idea of transformers, and we emphasized generative AI. So as we know now, generative AI is the underlying technology behind ChatGPT, GPT-4, Claude, Bing GPT, a wide variety of models. And now you have a good idea of how those models are trained, what their strengths and weaknesses are. We know that it's not a good idea to try to use them as like a replacement for direct search, because the models generate likely responses. Often that gets called hallucinations, but that's always going to be a risk. So they're great at synthesizing information, pulling information together, comparing, reasoning tasks. And you can augment them, and so they can do their own lookups. But even then, it's entirely possible they might be filling in information that they're unsure about. Then we talked about another technology that you can use to augment generative AI models, and that is LangChain. So with LangChain, now, you can augment the models by creating memory stores that the models can call on, and that will do a better job at mitigating this problem of hallucination. Or you could even build a much more sophisticated system where you let it generate whatever it wants to, but then you might do a lookup on the information and validate, sort of all in the same process, validate what's being generated. You all might have heard of not just one, but multiple cases now of lawyers getting raked over the coals by judges because they have prepared documents for court using ChatGPT, not checking. So they're using ChatGPT, in some cases they weren't using Bing, just ChatGPT, which is completely walled off. And it generated, of course, very reasonable sounding case law, very reasonable citations of particular cases that were decided in particular ways, which of course, what's coming next, do not exist. So rather than taking that extra step of actually seeing whether those existed or doing something more sophisticated, because again, these were lawyers, these weren't programmers, of building a system that would double check it as it was coming out, they just took it, believed it. In multiple cases, they actually asked ChatGPT itself if these were real cases. And of course, it said yes, because that's a likely response. So then they presented this information in court for made-up cases, which is not good for your legal career. So we also learned that generative AI are not the only kinds of transformer models. As a matter of fact, it's just one kind of transformer model. So last week and some of this week as well, you've been exposed to other kinds of models as well that are also transformer models. Many of these models are smaller than these large generative AI models, and they have different strengths and different weaknesses as well. But know that transformers are a powerful general purpose learning algorithm, which can be used in multiple ways. Generative AI uses just what's called the decoder transformer. As we talked about, that's not, it's kind of a bad name, but it's just one particular type of transformer that has a very large feed-forward network, which allows it to do much more complex reasoning and also a representation and much deeper learning. So that's where we've been this entire time. A couple of things have changed since we started. One is the significant development of very capable but much smaller models. Right now with GPT-4, You'll notice if those of you who've used GPT-4, how slow it is when it's generating. You can actually watch it as it's generating the text. And that's because GPT-4 is huge. We don't know how big, but we know that it is huge, so huge that OpenAI is unable to make available the longer context versions. And remember the context being how much can the model itself actually attend to at any one time. This is different than external memory. This is different from the weights of the learned models. This is what it can actually apprehend and deal with all at once. And we know that if you can fit things into the context, you're going to get much better solutions. So right now that's pretty limited, and it's limited because OpenAI can't get enough GPUs. So OpenAI, which is worth billions of dollars, can't buy enough GPUs because they're not available. And that's the kind of horsepower that you need to run GPT-4 for millions and hundreds of millions of people. So in the last week, actually near the beginning of our class, a model was released called Falcon. And Falcon is a competitor, an open source competitor, which is much smaller than even ChatGPT. ChatGPT is 175 billion parameters. Falcon has a 7 billion parameter version. It also has a 40 billion parameter version. And it's getting performance that is on the level of GPT-3 and in some cases on the level of GPT-4. When it is 10 to 100 times smaller than these models. It's also much faster and easier to inference with, and you could run it on your local machine. So this is a huge sea change. There are other models that also were going down that path. I've mentioned these before, Llama, Red Pajamas. Falcon has been solidly outperforming all of those, but there was a problem. When it was announced at the very beginning, and it was announced right near the beginning of this course, their licensing model was interesting. You could use it for academic use, but if you use it for commercial use, you would have to give 10% of anything you earned using the model to the owners. That's a lot. So they recently changed tack and they made it completely open source for full use using the Apache 2 license. It's a very permissive license. And that means that now we have at our fingertips something that we could run locally. Last week, you learned about how to, or was it this week? The weeks blend together. At some point, you learned about training. I think it was this week. Yes, this week you learned about training models. So that means you have a model which is small enough that you yourself could give additional training to, and yet would have the capabilities of ChatGPT and some capabilities of GPT-4. That's a huge advance and great news, because that means that we very likely, for many of the things we want to solve, are not going to be dependent on privately held models that we can't fully describe or understand. Michael.
I guess that we talk about this concept quite often, like run locally.
Yeah.
I mean, I guess where we draw the line, how much resource we still need in terms of locally. I mean, we still need a 5A100 or sort of like that. What's your typical on your mind to say when I say I can run locally? What does that mean?
Yeah. So I use that pretty broadly. So I mean running on some device that you have control over. That could be a web-based, and actually for inferencing on these things, that can be done even the 40 billion parameter model can be run on higher end consumer grade hardware. You might have to use some of the libraries from Hugging Face, because remember, all these are transformers, which means that pretty much all of them can benefit from the Hugging Face libraries, which allow you to run much larger models in much smaller hardware. So when I say locally, I really mean it. You don't have to own a DGX A100. If you want to do extensive training on it, you need to have more hardware. But even that can be mitigated by using the Accelerate library and other libraries from Hugging Face that allow you to do training of even very, very large models. Is just going to take you longer. But remember, fine tuning isn't too bad. And there are also other resources such as parameter efficient fine tuning libraries, which allow you to do really good training in a very efficient manner. So what I'm saying is, if you own a big GPU, you can do it. If you're willing to pay for Google Colab, Pro Plus, you can do it, or you can stand up AWS hardware, virtual machine. All those things will allow you to do this. And
Yeah,
Jeff,
I think last week in our chat, someone mentioned that they run some model on their MacBook or whatever, actually burned his computer.
Yeah, so the Macs, especially the M2 Maxes, they're great. They do a shared memory, and it's very very powerful. Okay, Marcus, you had a question, and Jeff, did you have a question too? I thought you had your hand up, or am I hallucinating?
No, I just an observation, with respect to what you're saying with the narrow kind of applications. So on the smaller scale,
Yeah,
I speak with a lot of early stage and growth investors by nature of what I do for Forbes. But one of the things that they mention is that they believe that there's the greater opportunity set is in these applications that are, let's call them $2 to $5 million kind of businesses.
yeah.
I mean, you hear about these large enterprise kind of applications of the large language models and the huge language models. But for the most part, a lot of the applications that will have true, meaning to, I'll say all of us, it's in the speed in which those types of applications will be built and deployed.
I think you're absolutely right. I couldn't agree more. I'm aware of half dozen. Yeah, I'd say half dozen variety of new businesses that have really accelerated from an idea to a deployed, working, not prototype, but solution in a matter of weeks to months to weeks. Some that have already accelerated through, gotten funding, in a time frame that you just would that I didn't think was possible. And they're leveraging the inferencing from OpenAI, right? It's very inexpensive. That's a quick way to do it. But even for I see these models as especially the ones that you can run, and again locally, meaning you own the compute. Even if you have very sensitive things, right? That means that it opens up to pretty much everywhere. Companies don't want to send their data to OpenAI. Who knew? A lot don't. Great. This gives you another opportunity. So I think you're absolutely right. You're going to be seeing many, many solutions that almost seem to appear out of nowhere. That's exciting. Let's see. And let me, Miranda, are there any questions in chat that I need to address here?
There was an interesting one on what do we mean by performance in regards to an AI model. So are we talking about quality of output or speed of response? And I kind of said it just depends on which performance metrics, but.
Exactly. So data science and AI has nothing if not a great number of metrics. So you can choose from a wide variety of metrics that you want to use, but really what it comes down to is what is it worth? So when people are coming up with metrics, I always suggest that they actually figure out what the worth of the model is. If it's going to be in business, then you actually write code around to instantiate the decision-making process in which this would be embedded. And then you do an analysis of what this would have been worth had you had this available in, say, the previous year based on your historical data. So that way you can actually run the numbers and say, what is the performance of the model? The performance of the model is $12 million a year. That's the performance. If we'd had it in place, if we're making decisions on last year's data using this, that is the gain that we would have seen. That's our best guess. And of course, you can have other measures as well. Certainly, especially if you get into more academics, than some of the more mathematically and theoretically motivated measures can work. But almost always it has to do with how well the model is doing its job. How long it takes or the compute that it takes to do the job is often sort of forgotten. But that's why, I like to have the dollars analysis of the performance of the models, because then you can subtract out of that 12 million. 12 million sounds great for a year, unless it's costing you $20 million a year to run. So even though you may have great, accuracy, broadly defined with the model. If you can't afford it, you can't afford it. All right. Anything else, Miranda, you think we should address from the chat?
No, I think we've mostly hit it. There's some good comments, good discussion, but I think we've got the questions.
Excellent. Very, very good. So we've talked a lot about how to think about these models, how to use prompting with these models, and also how to train these models. But we haven't really talked about how to share these out. So what we're going to be talking about now is how you can take a model, something that you've created, something that you've built, and then build a simple front end on it. And so you have something that you can share through the web. Now there's a trade-off here. The simpler interfaces, the ones where you take what you're given, are fastest and easiest to do. They also tend to be the most robust. As you sort of go up the chain of, okay, now I'm going to modify some things, then it starts getting a little bit more complex. And if you really want to control exactly what things look like, now you're out of the realm of these simplified libraries that will expose your work. And that's okay. But just know as you want to modify more and more, it may take you out of the simplified ways of sharing. That's all right. As we know now, coding has gotten a lot easier in the last 6 months. So even those you can create, but I would strongly suggest, especially as you're beginning to develop your solutions, to think about the simplest possible way of sharing those out. And one of the simplest ways of doing this is to use a library that's called Gradio. Anybody recall us talking about Gradio in the class? We snuck it in as a quick comment. So let's go ahead and take a look at what Gradio is, and then we're going to take a look at we're going to do some coding examples with it as well, and then we're going to see how you can use that with these generative AI models as well. So give me a quick moment here. Okay, great. Here we go. So, let me go ahead and share my screen over here, and then let me remind you that you can get to all the important stuff about the class if you go to our AI Summer link. Perfect. Thank you, Miranda. So let's go and take a look at the Gradio demo. And this is actually based on a course which is available in Hugging Face. That's where a lot of this material comes from. Hugging Face bought Gradio, which had been producing this a very nice simplified interface. So if you just click on it, then you'll be brought into the GitHub view. I'm going to stop my share for a moment and share just this window, because if I'm sharing the screen, I can't see y'all's faces, and that just freaks me out. Much better. So, all right. So if you click on Open in Colab, then it will start up Colab. And then, of course, then we can use this interactively. So go ahead and open that up. And go ahead and give me a thumbs up. Give me a thumbs up if you are here at this place. So a quick thumbs up using your icon. Okay, we have 1 person, 2, 3, 4. Okay, give me a red X if you're not here. Excellent. Okay, good. Then we're going to start running this because it's going to take a little while to install this. And if you have a red X, go ahead and put this into chat and we'll see if we can get somebody to help you out. Okay, let's go and run this. Yes, it's not authored by Google. Run it anyway. So here, since we're running in Colab, we always have to install transformers, and we're also going to be installing Gradio, a different library. And often you use GR as its identifier. So it's going to be loading a lot. We're just going to let it do its thing. And then we're going to start with a simple hello. So a couple of things here. One is that this is a different way of thinking about how programs run. Those of you who've done some programming, the program that we've done here generally, the programs have run sort of top to bottom, right? So you write a function, when you call the function, it runs, and then you get the results, and then you do something with it. You might call another function, then it runs. So kind of top to bottom. If you want to think about it a little bit more functionally, then it might be sort of out to in, but generally that's what happens. So one thing that's going to be a little bit different here is that you can't write programs like that and have them run well when you're interacting with a human. And sometimes even when you're interacting with other programs, right? But definitely when you're interacting with a human, they might click on one part of the screen or enter something and then say stop. And then it's got to be driven by what's happening. It's got to be driven by the events. So the first thing that's going to be changing is that how these programs run is going to be different. And that's the one thing which is a little bit confusing sometimes when you look at these programs, because it's not like, oh, well, where does it start and where does it stop? It has to do with the interaction. So looks like I'm done running here. So I'm going to go ahead and click on, I'm going to define my function here. I'm going to do a couple of things here. One, I'm defining a function called greet. And all the greet does is just return. So there's all the coding is in the return statement. That's how you know you're at a simple function. It takes hello, then puts the name in there, and then says exclamation, bang, bang. They're not bangs, so they're exclamations. Then we have this line, demo is defined as Gradio, GR, interface. So this is the interface method. We give it the function. So we just say function is greet. We give it the inputs, we give it the outputs. These are called shortcuts here, where the inputs, it just says, you can feed it a string called text, and you might guess you can feed it other kinds of strings as well. And that means it's going to give the default behavior for a text input. And it's going to do the default behavior for text output. But notice I don't have any print statements. I don't have any start now, end now. All I'm saying is launch. So I define this thing and then I say launch. Let's see what happens. So a couple of things here. One, to show errors in Colab, set debug as to true. Okay, so this is not running like a normal thing. Also, look at this. To create a public link, set share is equal to true. That means that really what it's running right now is like it's running its own small web server. It spun up a whole lot. That's why it took so long to load everything. So right now it's running its own mini web server and serving up this web page, which is interactive. So up here, let's take a look and see the elements that we said. We had function greet, so it's going to be doing greeting. Inputs are text, outputs are text. So, so it has input, and it figured out that the input, notice here that the function greet had name. Notice that I didn't name the input, but it figured out that the input was going to be the very first parameter that went into the function. And so it knew it was named greet. So a lot of is happening underneath the covers. It knew that that input was going to be name, and so it labeled it for you. So let's see what it does. Okay, my name is Jesse. All right. I'm going to hit submit. Then it says, hello, Jesse. Notice nowhere in code did I say run this. Instead, what happened was I put in, first of all, it presented this nice text interface. I put in Jesse, then I hit submit. That triggered events. So behind the scenes, it's handling the events. And when I hit submit, it ran greet with the function, with the name, with the data that I put in, name, and then returned a result, which it sent to output text, which was right here. So let me pause for a moment. What questions do you have about this so far?
Hey,
Jeff?
Jesse, yeah, for simple forms like that. So is it just like the design of it? It's just making some assumptions and just making as simple a design as possible on what that front end would look like.
Exactly.
So it'll, okay.
And that's the idea, right? If you accept the formatting as it comes, you're good to go, right? And so, and we're often run into problems, and this is the most difficult kind of client to have. When they say, they start with, I want it to look like this. And many people are visual. And so they, but it's like, okay, immediately when you say, I want it to look like this, now we're going to custom from the very beginning. So even if you can just start with something that just shows the functionality, it won't look like this later, but we got to test it out. That's really the way to approach it. And especially for us, the nice thing here is, and I'll share this again. Notice that it has these buttons defined for me. It can clear the output for me. I didn't have to program that. It has a submit button. It has a flag button. We're going to learn more about that in a little bit. But what that does is it allows the user to say, hey, something is interesting or something is wrong. They click flag, and it saves the state of everything for you to examine later. It stores it in a special place where you can go and grab it if you want to examine anything that your users flagged. A great way to learn off of what your users are giving you. But can I make this blue? No. Can I have the submit button in front of the clear button? No. So this is all set, but that also means that you get this full, completely functional, with one line of code. So that's the trade-off. Other questions? And Miranda, if I could call on you to help me, because my machine is close to crashing. I don't want to stop it right now, but that also means I can't see people's faces when I share my screen. So if you can call out people so they can speak, and that way I won't have to keep on sharing and unsharing my screen. Question.
Okay, call out for raised hands.
Yeah, call out for raised hands, exactly.
Okay,
or someone can also just speak too, or something comes up in chat. All right, let's go to something a little bit more sophisticated now. So a couple of things here just to remind you. So the big difference here is that this is event-driven programming. It's done for you. It's kind of hidden from you. So all the events that are happening, when I click submit, what's happening is an event, an update happens, and it lets the system know that whatever was dependent, whatever was associated with name, now needs to be updated. So it knows that it needs to rerun interface and update output. That's what's happening under the covers. Let's go and get a little bit more sophisticated though. So that interface class that we were looking at before. So it's this right here. It's a class, right? And it takes in a function, inputs, and outputs. It also does a number of other things, but those are the essential ones that you must have in there. So inputs and outputs can be many different types. We're just using text for right now. But let's go and just expand a little bit of what we did before. Notice that here we're saying inputs is going to be a text box with a label, with this many lines, with a placeholder. We'll see what that does by looking at it. And then the outputs is going to have a label called greeting. Okay, so up here, notice that the way that we did it before, we just said, we give it the function greet, that's the same. And we said inputs text, outputs text. And when we use those shortcuts, what we're saying is, hey, you figure out what the input is going to be, because I'm saying it's text, assume that it's going to be in the same order as the parameters I'm feeding to the function. So you figure it out. Outputs are going to be text. Now what we're saying is, okay, let me be a bit more directive. My input is going to be a text box with this label, this number of lines, and this placeholder. My output is going to be a text box with greeting. Now, still notice here, even though I'm being much more directive, I'm still not saying name goes with this input. Instead, the association is positional. First parameter that goes into the function is mapped to the first input method. The second would be mapped to the second, the third to the third, the fourth to the fourth. So that still is something which you, with interface, you don't get to hardwire. This is, interface keeps it simple, but it also means that you're stuck with whatever order your function has those parameters in. Let's run this and see what it looks like. So yeah, so now it's running up on a server. Okay. So now notice a couple of things here. It, instead of just before when we ran it, it assumed that the name of this was name because it got that from the name of the parameter. Here, what's happening is that it's labeling it name because we told it to label it name. This now, instead of just saying output, is saying greeting because we said, call it greeting. Notice here that we had 2 lines. So now you have 2 lines right here, 2 lines of space, and the placeholder is name here. So it puts in gray in their name here. And then everything else is as we sort of anticipated. Think about all that's being done for you. So, you know, to do this from scratch would be a lot of work. Now it's just not bad at all. So here I'm going to do Jesse again. I'm going to hit submit. Again, it updates, it runs through, creates the greeting. Questions so far about this? All right. Let's do multiple inputs. So let's take a slightly more sophisticated model, function here. It's still great, still greet, but now I have 3 parameters instead of just the one. So I have name followed by is morning, followed by temperature. And so now I'm going to define salutation as good morning, and then if it's morning, else it's going to be good evening. The greeting is going to be, and you might recognize this, I don't know if we talked about this before, but this is a way of doing string formatting. So it says, hey, take the first string, put it here, take the second string, put it there, put the third string, put it here. So this is going to be salutation space name period. It is temperature degrees today. And then it does a calculation of Celsius, and then it returns 2 things. So this function returns 2 things. It returns the greeting and Celsius. Okay, so now we're going to be using our interface class right here. And remember, we always have to feed it the function first, our inputs, our outputs, and then, oh, this is a new one, examples. Well, let's see what we're doing here. Inputs are text box, followed by another text box, followed by something brand new. I'm sorry, no, text box followed by checkbox, followed by slider. So the text box, the checkbox, and the sliders are all input methods. They handle different kinds of data. But if you notice, name is going to be text, is morning, is going to be a checkbox. And so it's going to, we'll see what it returns in just one morning, in just 1 minute. And then we have sliders, which is probably going to be numeric. Then the outputs, we have 2 outputs now. One that returns the greeting, and one that returned was a text box with the label greeting, another one with a number with the label temperature in Celsius. Again, notice for inputs and outputs, I'm not mapping that GR text box lines to, I'm not mapping that thing to name explicitly. It's associated because name came first and this one came first. So how does it know that where what somebody puts into the text box goes into names? It's positional. So again, first position is name, second position is associated with is morning, third position is associated with temperature. 4 are the outputs. First position is associated with greeting, second position is associated with Celsius. Let's run this and see what this looks like. All right. So I can do Jesse, is it morning? We gotta fix this. This is not great. That might mean yes, that might mean no, but I'm going to assume it means yes. Temperature could be improved a little bit too, right? Because I don't know if it's in Fahrenheit. I'm in Florida right now, and I think it's like 78, maybe 77, something like that. I'm going to submit it. Okay, so I'm assuming 25. So this must have been in Celsius. We can improve this a little bit. And notice these examples before. Remember when it said example up here? So notice how it's putting this into a function. It's putting this into a nice table up here. Wonder if it does something more. Let's go and click on it. Oh, look at that. So when you click on this, it changes the data. So these are examples that you can pre-run. So that's what examples does. It gives you examples that you can actually run just by clicking on them. You click on them and then you hit submit. All right. Questions around our function as it stands right now? All right, then I have a challenge for you. I'm gonna. Are we ready to do breakout rooms, Miranda?
Yes, we are.
Okay. So I'd like for you to take this code, go into the breakout rooms, see if you can improve it. So we pointed out a few things that just are not great. Like we don't know that it's asking us for temperatures in Fahrenheit. Also, it always starts at 0. Right? Is that a good place to start? Would you rather start someplace else? So see if you can tweak this code to improve it. You don't have to do huge changes. Maybe it's just labeling. See how you might be able to improve the code. We're going to take 10 minutes to do this, and then we're going to come back and we're going to discuss how we improve the code. So let's do a 10-minute breakout. Remember, when you go into breakout rooms, share your screens. Talk about how you're going to be fixing the code. When you come back out, be ready to share out how you improved the code. We're not going to use a breakout document for this because you're just going to be each coding on your own. I'm going to call on people sort of randomly to share how they improved their code. All right. Any questions before we go in? And what I'll mention here is that a really useful link for you to have is the documentation. Let me give you a link to the documentation. And we'll be looking at this as well in just a little bit, but here is a link to the documentation. All right, we're going to open up the rooms and we'll see you all in 10 minutes. Okay. I think everyone else is actually in the rooms. It just takes a little bit to update. I'm completely dependent on people seeing people's faces. It freaks me out when I can't see people's faces. So I might do a reboot in a little bit so I can get that back.
Yeah, I just had to reboot myself. It was, my computer was just really over it. So, I'm with you.
Going all right so far today, you all think?
Absolutely.
I'm going to be getting into blocks just a little bit, but but primarily what I'm going to do is I'm going to show people how they can learn this. Because really, I mean, I think once you know, we might need to put these folks in. I think that once you understand the event-driven, then blocks make sense. If you don't understand event-driven, then it's just like, what's going on? Okay, I'll be right back. I'm sure it seems like from what you were describing before that ChatGPT simple prompts does still pass the third grade reading test. Okay.
Oh, I don't know if it does, because I don't know what the grading is. So some of the questions that they ask, they're multi-part. So like there's one question that literally has 10 sub-questions. So I don't know if they count that as one. So,
It would all be independent. Yeah. They usually score, but it was like 85%, right? If you counted each individually,
mhm.
that's probably a pass. So not necessarily a story there. I mean, other than even the advanced models can't get, and maybe a story to say that even the advanced models can't get some of the questions right.
Mhm. I think it's I don't know. I think it's interesting to see which ones they get wrong, because
Mhm.
there was like GPT-4, it was like there was a question on the exam that was like, how do you divide the word together into syllables? And so I would think that that would be something that GPT-4 would get right. So it was like to/geth/ and so GPT-4 chose to/gether. And I thought that was just really interesting. Maybe GPT-4 doesn't know about syllable. Or maybe it didn't.
Or maybe that's how it's tokenized.
That's what I was thinking. Yeah. I was like, maybe that's an issue of tokenization.
It could be.
Also, did you see the question that it answered about creating a new word?
No.
There was this question on the test that says,
Oh, yes.
isn't that interesting? So most technically, it was correct.
Mhm. Oh, that's hilarious.
New word. It's a new word altogether, a non-existent word. So, I mean, there's something to think about that.
Yeah. Wow.
That was so interesting to see, because I was like, why would it ever choose that?
No, absolutely.
That was so cool.
And that was GPT-4 that did that?
I think so.
Yeah.
It's fair. It truly is a new word.
Yeah, absolutely.
And it's crazy that there are people who might have read that exact question on the test and felt the same way. They might have been like, well, these words are like, they exist. So it can't be thoughtful. That's already a word. So I need to choose these ones that don't exist. But.
And, and that may be, I think that's valid, and that is, maybe there is an article in there. Yeah, we'll talk to Brooke. Maybe just, there are questions that cannot be answered even by AIs. That there are questions that AIs cannot answer on this.
And I wonder even how like personas would affect that as well. Because it kind of made me think of how people on the autism spectrum sometimes think very literally, and so sometimes these questions are really hard. Because I need to close the breakout rooms.
Okay.
That's what I thought as well. And I was like, that's unfair.
Absolutely.
So
that's fascinating. That's a whole new way of sort of testing for the neuroatypicality. Is this understandable to everyone? Perhaps something else to add to our list for the summer. Welcome back, everybody. Other people will be here within about 20 seconds. Welcome back. Welcome back, everybody. So you got a chance to modify this code a little bit. You saw where the documentation was. who'd be willing to share some modifications that they made in the code? Go ahead and raise your hand if you'd be willing to share. Brian, terrific. You can share your screen if that's all right and show us what you did.
Sure. Okay, so hopefully you guys can see now. So it's probably easiest to start with what it looks like. So we switched the checkbox to a radio box. We found the info, so not just the label for temperature, but you can do the info, which we said in Fahrenheit, so you knew that. We also found that you can set a value that sets the default value, because starting it at 0 wasn't particularly helpful. So now when it loads, I mean, the name's pretty much the same, but time of day, that's taking it as a string. We had to we played to see that. And actually we changed these down here to work too. But for the code change, we had to change salutation, because is morning, since it is using the radio, returns a string. So then we could just say good and it drops it in. And then, like I said, there's the value and the info as well.
Nice. So really just a few changes in the code, and you have something which is already looking a lot better. So
yep.
I especially like the info. A lot of people use these interfaces, and they use these interfaces specifically to share what they've done with these transformer type models, either the generative models or other models as well. They're designed to sort of share out things that are very much like what you want to share out. So before you start going to the path of like, I'm going to do something completely custom, I might suggest that you do just like Brian in his breakout room did, which is explore what's available to you. What else have other people done? Is somebody else willing to share what you did if you did something maybe a little bit different?
I believe William has his hand up.
Great, William, yeah, share what you did if you would, please.
Oh, okay, yeah.
Or did you have a question?
No, I can share. Sorry, I was trying something else out, and so now it's a little bit kooky, but I'll go ahead and share it anyway. So yeah, so we didn't do a whole lot differently, but we did go in and change a couple things. Where's the so like one of the things we did is we went in and added like another option here, which is not really that interesting. So we had a cloudy, and then I was exploring how we could change the little slider thing, copying and pasting some code from the documentation where you could like add some text and like have some more feedback on that. Which is what was shown previously. And then we are getting some weird error, but it actually looks like this might be working now. Oh, yeah, so getting this weird error right now, but I'm not sure what's going on with that. And so really not a whole lot else that's that interesting, but it was fun.
Excellent. Very, very good. I love that. Yep, and experimenting, and of course being able to take a step back if you need to. So again, this is the idea of sharing functionality of models is kind of well-trod ground, and you can go and see how other people have solved the problems that are very, very similar to the ones that you've had. So let's go and take a deeper dive, just very briefly, into other applications of Gradio. So we're not gonna. I'm gonna assign some homework. I know it's the end of the session, but I'll be assigning some things for you to try out, because if you do try that out this weekend or later on today, this will really cement your understanding of Gradio. But let's go and take a look at Gradio in using very explicitly these models and how you call up a model and then share that model out. Give me one quick moment. So if you go in and you share, I'm sorry, if you go in and if you take a look here at, so we're back at our AI summer, go ahead and go into 4.3. So this is notebook 4.3, Gradio and Hugging Face spaces. Click on that. And let's go ahead and open this in Colab so we can run this and see what this looks like. You'll see things that are pretty familiar here. So again, we're running a new instance. So you have to say, go ahead and, you know, install Gradio and Transformers. It's going to take a little bit for it to do it. We are pulling in Gradio, we're pulling in Transformers, we're pulling in NumPy, and we're also pulling in Hugging Face Hub for a notebook login. We may or may not actually go in and do all that, but I just wanted to get up to so you could see what this looks like for an actual application here. So let's take a look and see what the code looks like. You've seen this before earlier this week, where you're pulling in, and this is from Abby's space here, where you're pulling in the name of the model. This is BERT Emotion. And we're saying which model we're using, and we are choosing which tokenizer we're going to be using. And we define our labels because we're doing sentiment and we're having it categorized based on these. So all this is what we did earlier. Now we're going to do the Gradio part. What's our function? Our function is called predict sentiment. It takes in text. So already we know a couple of things. One, there's going to be one input method. It's probably going to be a text box. So we have, we define our inputs here, and so inputs, and you will notice we're putting a function right here. So inputs, we're running the function on tokenizing it. We're doing additional work right here so we can get probabilities and then get the predicted class. So I don't know if we got into this detail, but essentially what's happening here is we're just predicting sentiment. So let's go and see what the Gradio interface looks like. So we're using the interface function. With Gradio, the simplest way of getting things to run is to use the interface class. We're going to take a look in just a moment at another class which allows you to do much more fine-grained changing and modification of how things look, called blocks. But with interface, remember that we need to define the function, the inputs, the outputs. We can also put a title and a description and examples. And so that's all, you know, this is for all the work that we did before up here. The only thing we need to actually expose this new sentiment model out, or this new sentiment function out, is these lines of code. And then you launch it, and then you have a nice interactive space. So here's how you do the modeling part. And you can imagine up here, this doesn't have to be a Hugging Face model. This could be an API call out to GPT-4. This could be output that you're getting from LangChain. This could be anything. But to expose it to the world, you have to come up with a function, which is going to do the thing. And in an interface class, you give it that function, the inputs, the outputs, and you're off to the races. So this is generally how you take work that you've done before, and then you expose it. What questions do you have about this? Let me ask you, what are some possible applications that you can think of now that you have this capability of having Gradio? William? Or is your hand still up? Okay.
Sorry, my hand's still up.
Yep. Jeff?
Yeah, if you need user input other than text, so if, like, let's say you want to read a PDF, for example, then could you actually use, or are there Gradio functions that allow somebody to drag and drop or import functions? And then on the backside of that, if you wanted to take that input and then convert it into another product with the output, then, you know, place that that produced file in a specific location as well.
Absolutely. So, matter of fact, when you take a look at the documentation, and here we'll see this in a couple of different ways. If we go back to our demo, here, you'll see, and pardon my heavy scrolling here, you'll see we were doing pretty much text. Come on now. We were doing text. There we go. Okay, great. So we were doing text. But look down here, you can do, and we did multiple inputs. We did text and we did numbers, right? But then you can also do audio. You could do images. You could do data sets and files. All of those things are possible. So with images, for example, you know, you have input image. So you have an image method. For audio, you have, and if you go down here and you take a look at the inputs, you have, in this case, it wasn't, you were generating an audio file, but here, you know, you have audio as a possibility. So if inputs microphone, output audio, you could have input camera, input file selector. All of those things are possible. And then you can do whatever you need to. Your function can be doing an awful lot in the background. And then when you're ready to return it, then you just have that as the return part of the function. So you can wrap all your work into a function, which has outputs that are in the proper order. I'm sorry, inputs which are in the proper order, meaning the inputs are in the order in which you want them to appear on the interface. And the outputs are in the order that you would like to have them appear in the interface. And once you have those two things, then you can just wrap it around, wrap that within an interface, and you are off to the races. So now that you know this, what are some possible applications that you can think of? Does anybody want to build something that can be used in a classroom? Jeff.
Yeah, I'll share. So one of the things that I was looking at and have been working with financial professionals is taking legal documents. So let's say a sales contract, for example, and then taking that, a PDF typically is how it's presented, and then converting that into an Excel forecast or a spreadsheet that shows revenue recognition. With the decreasing number of accountants or professionals that are entering the accounting field, a lot of that is just very rote kind of translation from the plain language in the contract into specific, let's call it 3-year, 1-year, 5-year, whatever the tenor is of the contract. So taking that PDF, what I think of as unstructured data, and then structuring it, or the output of a structured Excel spreadsheet. That's one example.
That's a great example. And now you'd have to have a place to run this in the simplest possible instance. You could be running it on Colab. Probably doesn't scale as well as you might need it to, but you can absolutely build it on anything. And as you saw, you can create a public link. So you're kind of there, especially for a small number of people interacting with this. What other ideas do people have? Jennifer, yes.
I was just thinking about the audio uses. I know there are probably some tools out there, but if you wanted to, I guess, have it summarize all the audio that was collected within the last 20 minutes and then use that audio to teach or give direction or build on major points. So either for yourself or for facilitation with a group, that could be used in a business or school setting.
Absolutely. Absolutely. I think that's a great example. And keep in mind that, even if we're running on Gradio, this is something that you can spin up and then make available for your class, for example, like right then, right there. It's not going to be persistent, but it's something that you can have available. Here's the link. Go ahead and answer these questions, or here's the link. Go ahead and experiment for a little bit, and then we'll talk. These are things you can spin up very quickly with little or no overhead. Any other ideas that people might want to share?
So Jesse, what we look at doing in tech transfer, we look at supporting faculty. So I'm always thinking of ways we can help support faculty innovation. And one tool I'm considering is how we can match up those faculty members who have early stage technologies and possible strategic partners that would overlap quickly.
Ooh. Yeah.
Right? In terms of speeding up the process of the matchmaking process, if you will. So I'm thinking how to do that.
Yeah, so you can imagine, for example, with that, you know about LangChain and you know about the documents, and so you could have documents where the partners, the possible partners, their descriptions. Strategic partners they're all, you could have they could have multiple documents where they're described, and then the faculty member that can describe their research. You can imagine, describing the research and then saying and asking the model, what are some strategic partners that have similar interests and backgrounds? Great, and then it actually generates something for you. Now you can have this interface that you could also just have up and running and say, hey, describe what your research is. And it's going to return as text, the generated text of given the partners that you have in mind, possible connections. Hey, you can build that interface like right now. So as you've seen, the speed between the idea and actually developing, now it's just a matter of frankly, knowing what you know now, you could probably build that in a couple of days or a day.
Wow, that's cool to think about. Yeah.
Anything else that other people would like to share? Then I'll share. So we're going to be spending the rest of this summer as part of the Data Science for Social Good, building solutions for teachers and for university and also high school instructors to build tools that they can use either in preparation for classes or in classes. And almost all of these are going to involve these type of Gradio interfaces. Almost all of them are going to be involving that. So some of the examples are, given an article as a PDF or a book chapter, generate 10 multiple choice questions that have explanations of why each answer is correct or incorrect. And this could be something which you can imagine a Gradio app, because we know how to do the back end now. It's going to be a prompt with backing documents using LangChain. Front end could be something that the teachers themselves would use, which is upload your PDF, and then out comes 10 questions as a text, and then you cut and paste. Or out comes a CSV, which you can import into Brightspace. Or the interface looks a little bit different, and now you're actually having the students trying out directly on the Gradio. They can experiment directly on the Gradio and learn directly off of that as well. So many possible uses. Let's take one quick moment, and we're going to take a look at the next level of sophistication. We've talked about interface, which is the simplest possible. Now we're going to talk about blocks. Blocks are a way to give a little bit more definition to what's going on in those, and also gives you more control. So blocks are a little bit more involved, and they they give you more customizability. Let's go ahead and take a look at these. Then we're going to take a break and finish out our AI summer. All right. So before we saw that we had a function that we would define. Stop. Okay, good. So before we were just calling interface. This is a little bit different. So here we are defining a new function. This is our function that we're defining, and it's just called update, and it's name. So now what we're doing is we're defining block. And this is the full definition, excuse me, of block. So demo is defined as block with demo. So this is how you define the block with demo. So here we're having markdown. So this is allowing you to do formatting of what you're creating. So it does a top level header of hello world, and then regular text saying, start typing below to see the text output. Then we have our input, where we define our text block, and our output. Notice this new function that's called change. Remember before I said that when you hit submit, that automatically in the background, it knew that a change had occurred and would propagate that and would rerun the function, and so it could redo the output. What blocks does, in addition to allowing you to do more formatting, is to control exactly what those events are and what they trigger. So in this case, this is defining what the trigger is and how it changes. So let's go and just run this and see what this looks like. So, all right, now it's hello world and a little bit more formatting here. So already you can see that you could use just block. You could just use blocks if you wanted to, just as like basic formatting control to give you some more control. What is your name? We're going to do Jesse. And notice what's happening here. Every time I type, it's updating. So that's not the behavior that we had before. So now what it's saying is every time that input changes, it's going to trigger a change here. That may or may not be the behavior that you want, but maybe you can imagine having this being a slider, and you want to have real-time feedback of what's happening when you're changing that slider. Blocks is a way that you can do that. So that's about all that I wanted to talk about with blocks. But I'll take any questions you have about blocks. We're going to be showing you in a moment a way to learn more and how to take the next steps with all of this and how to learn more. Any questions, though, about blocks? All right. So we're going to take a break here of about 5 minutes, just a break for people to take a step away. When we get back, I'm going to be talking about how you can learn more, what the next steps are. I'm going to be pointing you to some resources that are going to be important for you to keep in mind, and also pointing out that in a real sense, generative AI is the best way to learn about generative AI. Then I'd like to take some time to talk about projects and sharing some of the ideas, and these can be only like slightly baked ideas that you have that you want to say, I think I want to do this, all the way up to I'm going to be doing this. Can I have a show of hands right now and give me a green check if you'd be willing to share after the break, so you have some time to think about this. Just share like 2 or 3 minutes about what you're going to be doing. And remember, this is going to be a great way if you want to solicit students to join in with you. We have students here. We have students who are watching the recordings. So if you're interested in having students join you in your work, now's a great time to advertise yourself. Give me a green check if you'd be willing to talk a bit about the projects that you're thinking about. And remember this, okay, great. Isaac, fantastic. Cam, go and leave those green checks up.
And just to clarify, this could also be things that maybe they tried to do during this week or tried out
Absolutely. This also, absolutely. This, because remember, we asked you to think about projects as you were doing. So any projects that you have been doing, maybe even completed or almost completed, green check for that as well. Leave the green checks up if you would. So green check if you're willing to share. All right, so 1, 2, 3, 4, 5. Okay, great. Let's go. I'm going to give you about 2 to 3 minutes each for that. Thank you very much. I'll be calling on you again. Let's go and take a 5-minute break now. So you can think about, 6, fantastic. Okay, great. Let's take a 5-minute break. We'll come back. I'll first talk about where you can learn more. Then we'll share about our projects. And then we'll close out our summer. All right, see you in 5 minutes. Welcome back, everybody. All right, we're in the home stretch here. So we've covered a lot of ground, and we're going to be covering, and this is not the end. Actually, this is just the beginning of you learning about generative AI. So how do you keep on top of everything that's happening? How do you know what's new? How do you learn new things? Well, I unfortunately do not have a silver bullet on everything that's new, but I do invite you to follow the Data Science Institute, either on the social media or through our newsletters. We do our best to keep up with what's most important in the developments of AI, especially around the area of research broadly defined. And so we try to keep you up to date with that. But one of the great ways to learn about new approaches, new techniques, is to use generative AI itself. So I've been experimenting over the last couple of days with different approaches for asking questions and getting responses back about recent developments. And I've discovered something interesting, and that is that, much to my surprise, the best way so far for recent developments to get updates and get them, or to get them explained to you, is actually Bing Chat. So it turns out that OpenAI, and there's some really nice plugins, but OpenAI plugins tend to do very simple things, especially when they're going after web pages. And all that they're doing is getting the first couple of, the context length, just a short context, and then they're making that available to you. I think what they're doing is they're trying to reduce the number of tokens. Bing Chat is a little bit different. So let me share with you something that I did here. Let's say that you want to learn a little bit more about Gradio interface versus Gradio blocks, because we only talked a little bit about Gradio blocks. So here's one thing you can do. Remember, you have to go to the Edge browser, but you can go to the Edge browser, and here I asked, explain, misspelled, beautiful, explain the difference in Gradio between GR interface and GR blocks. All right, so what it does do a search and then generated an answer. And actually not bad. GR interface is Gradio's main high-level class. And it's everything that we talked about, function, desired input, desired output. Additional parameters control appearance behaviors of the demo. GR blocks, low-level API, create more custom web applications and demos, still entirely in Python. And it gives you an example of GR interface. It gives you an example of GR blocks. So this is code that you can copy, you can run. You know how to use Google Colab now. So this is a great way to actually explore and to learn, and you can ask more questions. You can also ask it to generate you some code, but you have to be a little bit careful here. So here I ask, could you give me Python code that will take an audio file, use Whisper to get the transcript, and return the text of the transcript? And it produced something for me, but this is not the full picture. This is not going to run. But it gives me an approach which is directionally correct, and it uses GR blocks, and it's using the audio input as expected and the output for text. But it's not quite the full solution, but at least it's getting you in the right direction. Remember that always you're going to be iterating with these models. And so you can run this, you can say it didn't run, here's the error that I got, iterate again, have it generate and give you an update of it, because it will understand what the errors are and then can generate you better code from that. So
Brian has a question.
Brian.
Yes, tying into kind of what you just said, if you get put in a request like this and you're looking at it and you're like, it doesn't seem exactly right, what is the best way then to ask for another response that is hopefully better? Obviously with code, you can put it in and run it, or ask for test cases to run against it. But just in general, do you have an approach of, okay, this looks right, but I can tell something's off here. Let me ask again in a better way?
There are two ways to, there are multiple ways, but there are two main ways that I think about of going about this. One is, pointing out what the error was, and then asking it to iterate again. The following that you told me was incorrect, or is not true, or is not a fact. Can you restate using only the information that you find here? So pointing out the problems, and pointing out the problems can be, you ran the code, you got the errors, you show what the errors are. That's the surest, fastest way, because those errors are known, and very much provides excellent context for the model to then produce correct output. More difficult when you're trying to steer it, because it's sometimes you can steer it if it's non-programming by simply pointing out where the errors are and letting it try again. But usually for non-programming, that's a sign that you have not provided enough context to begin with. So how do you fix that? One, you could try a persona, or you could give more context. And sometimes you have to start over completely. You know, when it starts getting wound around the axle, and sometimes you have to start over and rethink what your initial prompt is going to be. Second, it also might mean that you need to give it specific resources. So either by using a plugin, or by simply including additional information, you might need to be giving it more context, so it gives a narrower, more correct, more of a response of what you were intending. Or you might need to try an entirely different type of prompt as well, such as the inverse prompt. You say, ask me questions until you have enough information to answer. So almost always it's not well-defined context. You can either give it more context after the fact by saying, you got the following things wrong, please try again. Or you can go back and have a do-over using persona prompt, using an inverse prompt, giving additional context by using plugins. One of those, but the problem really is context wasn't strong enough for it to be able to give you an answer. Or maybe the model's not good enough. You're using ChatGPT, and you need to be using GPT-4 or Claude or Bing GPT. Does that answer your question, Brian?
Yes, thank you.
Absolutely. Other questions? Keep in mind that you can ask for the model to explain to you, given your particular background. So one excellent way of getting a better response is describing who you are. Please explain to me the difference between Gradio interface and Gradio blocks. I am a programmer with extensive experience in Python, but I have never used Gradio. Great. The response it's going to give you is going to be very specific to you. Or if you can say, I'm a brand new programmer, I've just learned Python, and I want to understand what blocks is doing. Or I've done a lot of web design, not a lot of programming. What is blocks doing? So this is your personalized tutor. There was a high school student that wrote an opinion piece for MIT Technology Review, where he was making the case that schools really ought not to be banning ChatGPT because it is an amazing learning tool. He said, it is your own personalized tutor. He said, yes, it's a slightly delusional tutor, but a personalized tutor nonetheless. And I think that's a great way of thinking about this. You always have to verify what you're getting out, but it absolutely can synthesize and pull together information and get you pointed in the right direction. Any questions about learning from generative AI? All right. Then let's go and share some of the projects that we have either been working on or have in mind. if you don't mind, thanks for leaving green checks up. I'm going to go ahead and go through and just ask people, and you're welcome to share the screen if you'd like to, or you can simply talk us through it. I'll give you up to 3 minutes per person. And if you need a little bit more time, just let me know. Janet, would you mind sharing first?
Sure. Hi, I'm Janet. I am a civil structural engineer, and my goal is to create an open source platform for engineers all across the United States to put information in, so that it would generate plans. All you'd have to do is, PDF plans into your model, and it would be able to generate structurally engineered plans. Or within that, you'd be able to ask any type of construction type question to say, hey, I'm here in the field. I've, done something wrong in the field. I forgot to put rebar, or I have to make this, window opening larger. How can I fix it? And hopefully it will be able to, the construction industry would be able to use that information and just automatically type it in and know that they're getting something that's coming from an approved engineer, whereas still the drawings still need to be signed and sealed by an engineer and reviewed. However, they've already been pre-approved because they've already gone through the system. So that's the goal of my plan.
Huge time saver. That's exciting. Paris, mind if I call on you?
Yes, I am a physician scientist, and I work in rheumatology, and so we have a lot of rare diagnoses, and one of my long-term goals is basically improving personalized medicine in patients with inflammatory arthritis. And a part of that is just empowering patients to learn more about their health and make informed decisions. And so I was thinking potentially we could build like a patient-facing platform where they could learn more, they could ask questions about their new diagnoses and treatment plans, and potentially, so instead of just going into some random web page, I guess that hopefully that there would be a way to streamline that knowledge into something that's more, I guess it's more credible.
Fantastic. And cool thing is, of course, it doesn't matter what the language is. You can generate whatever level you need. That's very exciting. Isaac.
Yeah, so I just started a small project earlier in the week, or last week, just to make sure I was understanding everything. And I use online recipes a lot, but I'm not a very good cook in the fact that I don't prep all my ingredients. So when in the instructions, they'll say, use this or put this into the pan. And I don't remember how much it was because that's up where the ingredients are and I have to scroll past ads. So I was trying to build a LangChain app that I could input ingredients, the original instructions, and have it rewrite the instructions so that every time it mentions an ingredient, it includes exactly how much of that ingredient, and including some cases where it's like, use only half of this or a third of this, and it'll automatically do that. And it worked pretty well. It had some issues. And then I started using like examples with LangChain, ran out of context length, started trying to do example selectors, couldn't install ChromaDB. And so I made a lot of progress, and I'm hitting a different weird error where it's not encoding something properly. And apparently it's a version issue with like requests and URL lib that other people have run into. So I don't know how to fix that. But another potential application is I also do research constructing AR applications for use in education. And the Magic Leap headset that we use does voice to text transcription, and it could be useful as a way to give students feedback or help during an AR lab if they're stuck or confused. We could like pass it up to some trained model we have that can help give them tips or explanations on why they got some simulation wrong or something like that. And that's something my advisor and I have discussed.
That's very exciting. That's great. And I love the recipes. Actually, I could use that too. Same thing. It's like, oh gosh, no, I don't need a new mattress.
Yeah, exactly. I thought it'd make a great browser extension.
Oh my gosh,
So-
absolutely. Oh, that's great. Jeff.
I was sharing a little bit of this earlier, but you know, just to kind of take the overarching or the broader view of it, it's essentially using legal documents, which are the kind of the basis of what I'll call the financial, you know, kind of world, and converting those into those word problems into the actual data or spreadsheets. And it starts with things like revenue forecasts, and then the second iteration of that will then be, you know, once you have certain sets of completion or certain completion hurdles that are met, how do you then reformat the Excel spreadsheet or the revenue forecast to then say, okay, in the first quarter we only hit 80% of goal, so then the actual forecast has to recalculate. And that's all based on, you know, regulations and accounting rules and regs that are, you know, that are set upon the CFOs and financial professionals there. So very similar to what Janet was saying, it's taking those PDF documents or the unstructured data that's there, you know, converting it into a structured kind of format, comparing that format to a set of, you know, regulations, which, you know, finance is very heavily regulated and has a number of different regulations that have to be abided by, and then, you know, being able to recalculate or re-look at, you know, the problem, you know, once you get past a certain completion point.
Nice use for LangChain to sort of do that loop where you have generative models sort of creating, and then you might have other types of models that check the work of the generative AI, make sure that it meets the criteria, passes the test, and then, yeah.
Yeah, I mean, the class has been fascinating, just understanding how the people that are currently doing it think, and how to then take it from the keyword to the variable and breaking it down into those each specific, you know, descriptive steps. Thank you.
Fantastic. William.
So I've got several ideas about how to leverage these tools. Obviously very powerful for a lot of things. I'm really interested in kind of looking more into some of the image capabilities that are a part of, you kind of touched on it a little bit today, and trying to understand a bit better about that. I think, you know, some of the tools that we've built in the past had to do with building some lightweight Python applications to view images and allow chipping of images or magnification of certain images, and identifying in an image an object of interest that can be used to train a convolutional neural network to find those in the future with this kind of AI system. So trying to find ways to generate the code more easily, more rapidly, and make it into a web application, that would be really neat. Also, you know, trying to deal with like multi-layer images instead of just like, you know, like hyperspectral imagery where there's many bands, hundreds of bands, you know, trying to understand how you can label all that data, find the signatures of interest. Also, not just like a lot of the focus has been on detecting objects, but also just understanding how they're changing over time spectrally is something that's really interesting. So it could be a fixed object, but it's changing. I mean, a simple example is a field where there's agricultural development, but it could be a building that's expanding and contracting. It could be, you know, a building site that's being constructed, and you know, the concrete's cooling, and that has an effect on where it's like settling, or you know, there's all kinds of things that are really interesting. And so trying to find ways to automate and creatively think about how to process that data. There's some totally unrelated projects that I'm interested in. I've been recently managing some real estate and financial matters for some deceased family members and things like that. And so there's a lot of opportunity. It's really a difficult challenge. I think there's a big opportunity to build tools to support that community of folks that are really don't have a lot of experience in this kind of thing, and need to kind of do that. So that's an area that I think there's some really interest. I mean, just trying to find the knowledge for a particular, you know, county and a particular state of like what to do in this particular situation. It's like a needle in a haystack, and you can read books on it, but they're generally like very generic, like they're not specific to a particular county or even a particular state often. So a lot of the information there. So it's something you have to go through with a fine-tooth comb, obviously using an AI model, to do that, because it may not know either. It might guess wrong about some of this stuff, but that's something I think could be really interesting to help with that. So anyway, I think I've taken my 3 minutes probably, but
Right, no, that's great. And that last one sounds like a great application for agents as well. So, have it iterate through until it gets close, and then you can do something a little bit more rigorous when you zero in. Fantastic. Cam.
Yes, thank you. These are all great ideas. It's getting me thinking more about a couple pain points. And to give people context on the call, what tech transfer does at Vanderbilt is supports faculty research and innovation. And technology transfer across the nation is something that's been changing and growing a lot. But it's sometimes very confusing for faculty to understand how to navigate that system. And I'm thinking of some ideas after going through this class of how we'd simplify that with some AI help to be a guide, like you said, like a tutor perhaps for the faculty.
Yeah.
So that we can get to know our customer better if you look at it that way, and looking at some solutions. I'd be very curious to talk with students if they wanted to get involved and dig in a little bit on that. And that would be like the overview, I think, Jesse. And on the as we drill down a little bit further, I'm very curious now, of how it would interface with, say, our Salesforce account, and how we take and sift through information there. I don't know the answer to that yet. But that's what we use for tracking. Is there a way to make that process faster? We also use Trello. A lot of folks on the call use Trello for organization. We do that a lot with on the startup side and technology side. So it might be a way to help speed those processes up.
There's a nice plugin for Trello for reading data in from Trello.
Yeah.
And with Salesforce, we now know that the models are very, very good about learning APIs. So even if there's not anything currently built for interacting with Salesforce, with your particular data model with Salesforce, we now know that models can iterate through and actually learn how to interact without a whole lot of, it requires some additional work, but this is not like you're trying to roll your own brand new Salesforce. You could interact with it in an entirely new way.
Right.
Fantastic.
Thank you.
Great. Anything else? So that's all the checks that we had. Anybody else like to share something they're thinking about or something that they have done? Yes, Chris.
Hello. Yeah, I missed the last 2 hours because I had to step out. So I don't know if anyone else has already shared, but well, first of all, I just want to thank Jesse, you and your team for everything for the last 4 weeks. Just learned a lot. It's been a pretty mind-blowing experience. And I've taken a lot of computer science. I have a bachelor's and master's in computer science. I've taken a lot of CS and data classes, and this is probably my favorite class after, in the last 20 years. So thank you so much. In terms of ideas, I actually don't know what exact ideas I want to play with. I guess I'm still figuring out what I want to do. But I guess what I would say is if anyone is interested in help in prototyping your ideas, bringing them to life, testing their viability, I want to just play with projects, like go deeper into this area and just want to collaborate or partner with others. So if that's something someone is interested in, feel free to reach out to me. But I guess more broadly, I think the biggest idea or takeaway for me from this whole experience is how much more powerful software engineering can be. I feel like, so I've been working for the last 15 years as a software engineer, and I really cannot think of anything as revolutionary as what I've just gone through. And I feel like for me to survive as a software engineer, I really have to become an AI engineer and have to really reimagine how I build products, what products I build, and Otherwise, I think a lot of software engineers will lose their jobs. So I'm looking forward to, I think, doing that and learning. So thank you so much again, Jesse and team, for getting me started on this journey.
Absolutely. Absolutely. And Chris, if you want to put in your contact information in the chat, if someone's interested in reaching out to you, that would be fantastic.
Oh, will do. And I will catch up on the entire recording after the class as well. So
excellent.
To everyone. Thank you.
All right, folks. So we're at the end of our time. We will hold our office hours after this, but I'd like to ask some favors. So one is, if you have found this helpful, and I'm very glad, Chris, that you have and that others have as well, share this with your colleagues. If you are at Vanderbilt, share this with your colleagues, share this with your chair, with an aim toward getting other people to participate in the project, perhaps over in this course, perhaps in our AI winter. So our AI winter is going to be an updated version of this course with technology that's new at that point. And it will be much shorter. It's over just 1 week. The first week of January, we'll be putting information out about that. And of course, next summer, we'll continue to have our AI summer as well. So please share out, again, with your colleagues, with your chair, with folks in your area, so they know that we're here and that we're a resource that they can use. I'll also point out some other resources that we have if you're interested in going much deeper with this. And in particular, I will take a look at our AI summer again, at the resources that we have there. And I'm going to point to, just added a few for you to take a look at. So let's take a look at those real quickly, and then we'll be finishing up. So down here under resources, I do teach a semester-long class in Transformer. It goes much more into the theory and applications of these models. So if you're a graduate student or you're an advanced undergraduate, you're welcome to register and to take this course, DS 5690. If you are a postdoc or faculty, you're welcome to if you're a postdoc, you're welcome to audit or to sit in. Same thing with faculty. I've certainly had faculty that come in just for particular lectures that they know that they might benefit from. So welcome all of that. So that's a good way to get a deep dive into the actual mechanisms which underlie all of these. All right, folks, that is it. Thank you very much for attending, sticking it out to the very, very end, and do please follow us on social media, and also you can sign up for our newsletter. But thank you again. We're going to go into office hours now. It's been a real pleasure working with you all. So thank you very much.
Thank you so much. Have a good day.
Thank you, Sophia. You're absolutely welcome. Thank you, Jennifer. Thank you, Michael. And Michael, thank you for all of your engagement. That was terrific. Victor, thank you very much. Paris, thank you so much. Thank you, Lou. Thank you so much, John. Great, and we'll now move into office hours. So what questions do you have?
I have a question. So I think I asked this question in the last session as well. But I'm just trying to get a clearer idea as to which of the tools, and we talked about a lot of tools. So I'm trying to figure out like what would be more appropriate for something like the project I described. So I'm trying to so there's a lot of misinformation out there in terms of like disease specific. So for example, I work in specifically in psoriatic arthritis, and a new diagnosis of this disease or some of the rarer diseases can be challenging to navigate through for patients. And so when trying to like build something which would, I know it's not possible to mitigate all the hallucinations, but trying to just make it a little more credible when they ask questions about their disease or the treatment options or anything related to the disease. So what would you, I guess the things I'm thinking about is, would you use something like already existing models like ChatGPT and then use LangChain and agents that like you were referring to, versus just building, like using something like Falcon that you mentioned and then just training and fine-tuning those? Like what which of those routes should I pursue? I was not really certain about that.
Sure. So first to talk very generally about when you might use an existing pre-trained model augmented by LangChain and maybe document lookup retrieval, is whether the concepts already exist in the model, right? So in this case, does a concept of psoriatic, arthritis? So yeah. Does that exist? If that exists already in the model, and it's a matter of actually getting specific information that you can draw on in your response, then it sounds like really, you're in the realm where something that's built on LangChain could do a good job. But if you're talking about something which is not well represented, for which the concepts have not been learned by the model. So take the example of models that were trained prior to COVID. There's this like, LangChain was not going to help you have a model that could respond reasonably with things around COVID. It's just like worldwide pandemic, but we have electronic devices where we can communicate in real time. But, and also the scientific understanding is that doctors don't believe, transmission through aerosols yet. It's kind of like, no, you need to, for that case, you'd have to retrain a model, right? Because medical understanding of aerosols change. Medical understanding of transmission of disease, the speed with which variants came, all those were like brand new concepts. So lookup is not going to solve that. So that'd be a clear case where you need to train a model with those new ideas, and so it can learn about modern pandemic, and aerosol transmission and all those things. In your case, talking more specific, I think that having a good vetted document store is really important, and to make sure that it is, oh gosh, what's it called, Miranda, Shara, when it's chopped up? You don't say chopped up. What is segmented?
Splitter?
What's that?
Splitter?
Splitter, yeah. So it's split in semantic chunks. That's important, because you want to have it. You want to be able to looking at the correct chunks. So paying attention to that is helpful. To make sure that it is, thank you, Chris, to make sure that it is actually there and not hallucinated, you can also do a second step where you can, so you can imagine GPT-4, ChatGPT does a lookup, does a retriever, pulls that into the context, generates an answer. Then if you want to be sure that that answer is real and not just hallucinated, yes, you can, in the prompt, say using only, that helps some. But what you could also do is, even before you give that response out, you can do something like, you could do a BERT model-based retriever, question answer. So this would be extractive question answering. And you could say, if I take the answer that I got, maybe, okay, take this answer I got, rephrase it as another question, give that to BERT. If BERT can't find an answer anywhere in the documents that I have stored, don't believe it, and regenerate until you get a response that it could find in the responses, right? That's perfectly acceptable. That's kind of like a special agent thing where it's like, okay, Can I find evidence that you drew this information from these documents? If not, go again, because you hallucinated that one. Again, not bulletproof, but at least you'd have evidence that what the answer that they gave, there's support for it. And that's all LangChain, existing models in LangChain.
As far as like what model to use, so you could use ChatGPT, or what would be the best?
You will have to try, because you know, if money is no object and you can get to it, then GPT-4 is going to be fantastic, right? But is ChatGPT good enough? And you'd actually have to, I would suggest that you have a suite of sample questions that you can use as a test, so that you just run, and then you can iterate through the prompts that you're using, the backing that you're using, whether your semantic segmentation is good enough here, you know, but you want to have like responses. And then you might even have yet another model, which takes a look at the answers to see how good they are, judges how good they are. That kind of metric is going to be invaluable, because you may find that you really need GPT-4. You have an idea of when you might need GPT-4, when the ideas are more complex, when there's more problem solving or chain of thought that's required, right? So if somebody is saying, I cannot do the following, or, you know, when it's cold and I try to do this thing, I'm unable to hang on to it, my grip decreases. How can I, you know, how can I fix that? That's a really tough. I don't even know if it's really a thing. I just completely made that up, right? But, you know, if that's all right, well, here are the issues that may be important. Here are some things to try. Change your grip, you know, use a different type of handle. You know, those are things that GPT-4 could synthesize from all of the information that's given that ChatGPT probably couldn't.
Sure. I guess because this is going to be patient facing. So if we use GPT-4, the patients would have to have access to GPT-4. Is that accurate?
Or you would, and you'd have to be paying for it.
Okay, and then so they would be able to. I mean, it's got a limit, right? So I can't actually share it with all of my patients.
Yeah, right now they don't have a good model, because again, they don't have enough GPUs. So if you want to be able to share it out where it's like a finished, you have like just a web front end, and then you pay for everything, it's gonna be ChatGPT, right? That's the one that you can pay for now and can scale up. But if you want them to have it, then it might be prompts. It might be completely prompt driven. You know, use this prompt, ask your question, then have this follow-up prompt, and so it can, you know, validate the answer a bit. It depends on who do you want to have owning it. Like if it's patient facing, in terms of liability, if the patient owns it, that's one thing. If it's something that you own, you know, that you're completely serving up, then that's a very different thing. So all of this play into the decision of which models you'd want to use, and what the architecture of your solution looks like as well.
Right now, at least as the first step, it's probably going to be like an RCT model where you would roll it out to 50% of the patients.
Oh, I see.
And not 50 and 50% of patients would not be, and then we'll have some sort of a questionnaire to see if that actually helps.
That's nice.
So at least the way I'm thinking about this now is you would just share like a link to this interface that we saw today. And then they could just go in and just ask questions whenever needed.
Right.
So I guess for that purpose, would you recommend like what? I'm just trying to think like what base model to build it on.
And about how many users do you think you're going to have?
So for example, it's probably going to be like 50, maybe. So to start with, so and then 50 users versus 50 non-users randomized.
So I'm thinking, yeah, you'll probably have to do ChatGPT. Because, do you agree, Sharo and Miranda? I just don't see GPT-4 as giving you enough bandwidth to be able to, it's not going to give you enough queries to be able to support that. Because even with the API, they still put a lot of limits on it. So it's probably going to be ChatGPT, which means it may not be as performant, but that means it's really important to have good backing documents that are well segmented and that you really iterate through your prompt until you have one. The prompt is probably going to have to be longer. It's a persona prompt is going to be more important for ChatGPT. So it's like, here's your expertise. Here's what you know, using only the information which is available, to you in this prompt, meaning it's going to be doing a lookup, answer the following, yeah, it's probably going to be ChatGPT.
That's helpful. Thank you. And the I guess it's going to use my API.
Yeah.
Okay.
So you'll want to OpenAI is not great about reporting limits. You can put limits on how much you'd have per day, but you can only get your reports like every week or every month, and so you can spend a lot of money without realizing that you have. So you'll want to put some safeguards like maximum amounts to make sure that you're not just caught by surprise with that. And the other thing that you can do is you might want to think about putting some safeguards in place where if people are asking non-arthritis related questions, that it says, I'm sorry, and use a really cheap model for that filtering. So you wouldn't use ChatGPT for that. You might use like a really cheap model and say, I might be misunderstanding, but I don't believe that your question has to do with arthritis. Or, honor system, hey, we're testing this out. This is really going to benefit other people. Please only use it to ask questions about your condition.
That's helpful. Thank you.
Mm-hmm. And please keep us in the loop about that. And also, if you would like to collaborate on anything, please let us know. That's a great project.
Thank you. Yeah, I'll definitely reach out.
Okay, fantastic. Questions from anybody else? Yeah, Sarthak.
I had a question regarding like how does OpenAI handle our data? Like when we ask stuff like that, does it share with the third party, or how does it work when it comes to like data privacy?
So a couple of different moving pieces there. One, if you call it using the API, you can opt out of them using your data for training.
Okay.
So that's something, and they actually defaulted to, you have to opt in if you're using their API to enable the data for training. So if you're using the API, that's helpful. It doesn't prevent them from, they say they won't use your data, but your data is still resident on their servers, right? And it's resident in a more persistent state because it's persisting chats across time, which means it's being stored someplace on their systems. Okay. And we've seen examples before where their systems have been compromised, and so you don't know that what you share up there is going to be perfectly secure. It may or may not be. If you are using the web interface, it is absolutely going to be used for training. Anything on the web interface is fair game. They make no guarantees about how it will or not be used. If you use plugins, that data will also be going to the plugin provider. So if you use a travel plugin, for example, because you want to have a conversation and talk about where you might travel to, then what's going to happen is that is going to be shared with that third-party site. So if that is like Kayak, for example, Kayak is absolutely going to get the full text of whatever goes through it, which is going to be your prompt. So Kayak has that, and then OpenAI has that. Same thing with Bing Chat. Anything that goes in Bing Chat, Microsoft is going to have. So you do have to keep that in mind. That's one of the reasons why I'm really excited about the development of these really powerful, much smaller models, because those can be run privately and data doesn't have to go anywhere. When I say run on your own, I mean your own instance, your own machine, but you have full controls over the security around the data, you know, full trip there, full trip back, if you want to.
Yeah, I was reading their website yesterday, and they said like if you turn on like the chat history and stuff, it's not going to be used for like training their model. So your data is not stored. That's what they said, but
well, it's stored. It has to be stored, right?
Okay, yeah,
it has to be stored. Training, and they may have trained. They may have changed their stance on training, which would be a smart thing to do. So if they have, I would appreciate that. Because it was a number of months ago that they changed the API where you could opt out of training for API. But if they change that for the web, that's great. Of course, they've had over 100 million users for months now, so they probably have all the data that they need at this point.
Okay. So what
They're
other
full.
like models do you recommend that has like more private? I mean, I have like the state-of-the-art response, but it's like more private and small.
For truly private, it's got to be a smaller model that you yourself could run on an instant that you spun up. So that's gonna, right now, the leading model for that is Falcon.
Falcon.
Created by United Arab Emirates, which is interesting. That's the staffing financial stitch, you know, they're the ones. Red Pajamas is there, but just is not performing as well as Falcon. And the only reason why people were not even talking about Falcon much a few weeks ago, even though it was outperforming Red Pajamas and the Llama-based models, both in terms of the amount of compute required to train it and then the performance after it was trained. Llama was trained on, I think, like 1.4 trillion tokens, and then it got, you know, good performance. This was fewer number of parameters and trained on only 1 trillion tokens, so less than half the compute, and was outperforming the Llama-based model. So very good performance. The smaller it is, the easier it's going to be to domain adapt or to fine tune or to do extra things with. So that's a plus. You can run it locally. Now they have the Apache 2 license instead of the stupid 10% of all the profits license that they made up before. So now it's an Apache 2 license. That's the one that I would go with if you really need something that was private, but it requires extra work. OpenAI is not bad though, you know, for, you know, especially if it's very clear that it's not going to be used for training, especially when you're using the APIs. It's not a bad solution. And you know, right now they're a smaller company. They're beholden to very few others. They're not beholden to anybody, but they could be bought, right? So at that point, the data gets bought too. So that's the trade-off.
Sounds good. Thank you.
Great question. Other questions?
Yeah, actually, kind of a question related to that. In terms of like getting your own like compute power, I guess, in order to run like a model in private, you know.
So the 7 billion parameter Falcon you could run in, I think you can, there was a 7 billion parameter Llama that you could run in Colab Pro. And I think you could run the 7 billion parameter Falcon in Pro, Colab Pro, or maybe Colab Pro Plus. So that's like a dead simple way to do it, right? Spins it up and you could run it there. The other fairly simple way, you know, would be an AWS instance, because you can get however large of an instance you need. They're not too expensive if you're careful about how you do it and when you do it. And then of course there's like completely local. That's another option as well. You'd want to have the highest end consumer grade GPU that you could possibly get if you wanted to run it locally. The Max, the M2 Max, where you have two M2 chips that are like together, those are not bad for running these larger models, because they do a good sharing of the memory between GPU and general system memory. So those are all options. Does that answer your question?
Yeah, I guess so. You want to look at like, or I guess here's a question: like, why is it GPU not standard memory? I guess.
Oh, and that's going to be changing, as all things. So right now, and William, I saw your question, and absolutely we'll answer that in a moment if you can hang around. So right now, it's almost like a computer in a computer. So main memory RAM is slower. It has high speed, connection to the CPU. You can think of CPU as having maybe up to like 12 threads going at once. So it's multi-processing, but only to a certain amount. Good bandwidth between the two, but not amazing. GPU, you have hundreds, thousands, tens of thousands of processes that can be running at the same time. So it's no comparison to a CPU. They're simpler. The things that you can run on a GPU thread, it's not really a full thread, but a GPU is processed for each of those, what are called cores, CUDA cores usually, for the ones that do most of the deep learning, are simpler kinds of maths, simpler kinds of operations, but the connection to that memory is extraordinarily fast. It's like level of physics is like the limit of how fast these cores communicate with that memory. So highly parallel, much faster, and can do specialized operations very, very quickly. So, but they're separate, right? And then between the two, the CPU and the RAM and the GPU and its memory, there's kind of a bottleneck. You can get faster. This is PCIe bus in most cases. Sometimes NVIDIA has like an NVLink, which is faster. The new architecture from Apple actually has them all on the same die and sharing quite a bit. And so it's a much higher rate of information interchange between the CPU and the GPU. The newest announcement from earlier this week from NVIDIA, brand new architecture called the GH100, which is going to be, it's all on the same die. It's all in the same. There's very little difference between CPU and GPU on the new system that they're going to be releasing later this year. So that it's blurring between the two because we're realizing that we need to have easier access to GPU. You need the speed, you need the high speed memory, you need the multiple memory processes. These GPUs are really good at doing linear algebra, doing matrix multiplies, vector multiplies, and that's exactly what's happening with deep learning. That's what speeds it up. So that means even though you might have 32 gigabytes of RAM, if on your video card you only have 4 gigabytes of RAM, that's generally going to be the size of the model you're going to be stuck with. Hugging Face does have a way of swapping in the model in and out. Used to be, if your model was bigger than 4 gigabytes, you were done. Now you can swap in parts of the model in addition to swapping in parts of the memory in a very clever way. So you can run larger models on smaller hardware. It just will take extra time. Does that answer your question?
Yeah, that answers the question.
Great. So William, you got a question? Yeah, so the data science master's program at Vanderbilt is 2 years long. You can think of it like an MBA program, but for data science. We emphasize quite a bit AI. As a matter of fact, Charo and I are going to be meeting, hopefully starting next week, more about teaching the programming class in a different way. So we're doing AI-assisted programming and sort of infusing that throughout the program. It is in person, full-time in person. That's how it's set up right now. We also do have projects. And actually, Miranda is a graduate of the program. From, was it just 1 year ago? Was it 2 years ago?
It was 1 year ago. Crazy.
Oh, okay, that's great. So, and Miranda was most recently at NOAA. That's why I have in my mind that it was longer. You've done a lot. in that year.
Yeah, well, I started my NOAA job while I was doing my master's, and so I think that's why it feels longer sometimes, because I've been at NOAA for 2 years, but then only a year ago graduated.
Got it. So over the summer, we do have a number of research activities going on. One of them is through the Data Science for Social Good program. In that program, we have a number of different projects where we're building solutions for instructors and for faculty at Vanderbilt, and also for high school teachers, especially high school teachers teaching English as a second language. And these are, sometimes these are small solutions of generate, given a chapter, given a text that I will paste in, generate questions, for low stakes testing, all the way to something that's much more sophisticated, like what Holly Tucker is going to be doing with this, which is a whole interactive game, role-playing game around the French Revolution. And so, you play the French Revolution game, and sometimes the king gets to stay in power, depending on how good you are at leveraging the different resources that you have. So using these models, and you can imagine a LangChain system that sort of assists in the running of this project. So we'll probably have at least a dozen projects of various sizes, some small, some larger, that we'll be working on. We'll also be working on assistive technologies for folks with disability, with developmental delays, or on the autism spectrum, in collaboration with the Frisch Center and also with Next Steps. We actually built a bunch of that technology last summer, but now we're having to rebuild it because everything has changed and it's much more capable than it was before. And with those, we welcome volunteers to get involved with that. We love for people to join in as they can. What questions do you have so far?
Well, one question, I was going through the application, website, and it mentions a bunch of different programs under the VUSE Summer Research Program. Like there's an visual thinking one. There's some that sound pretty crazy, like but there's a lot of really interesting things in here. And so I just wasn't sure, are these like specific things that people individually would apply for, or are these like maybe very specific programs for, I'm not sure what those are.
Sure. The other ones are, and I didn't mention them just because we fund them and we support the students who are doing them, but they're not ours, So these are summer research program. These are undergraduates at Vanderbilt that have applied with a researcher.
I see.
So together they write a proposal, and they can be funded through like School of Engineering or a couple of other places. But when we fund them, we suggest they participate in the AI Summer program. And then we also have other workshops that are later on in the summer around doing reproducible science, doing good data science best practices and everything along those lines. We used to teach Python and R, but we don't really need to do that anymore. But those are like projects where the student is working with the researcher and maybe a lab. So yeah, the DSSG projects are the ones that we actually collaborate with various stakeholders to carry those out.
I see. Okay. So it sounds like the master's program is the main one for an external person to really participate in. Yeah. Yeah, got it.
Absolutely, that's right. And also we do have an online computer science program as well. So like Brian, who was here before, just graduated from our online CS program. They also participate in research as well. So that's a way to have a on-campus and yet still have strong participation in the projects that we have. Yeah, but we do take, we have community volunteers pretty frequently that participate with us in different projects as interests arrive.
Great, thank you.
Absolutely.
On the same lines, like what can you take? Is there a way you could potentially take certain courses or like certain classes within the master's program? For example, I am on a K-23. I will be starting on a K-23, and so as part of that, there are a couple of like machine learning project, machine learning as my like career development goals. For example, I have some of the classes laid out there, and I don't actually need credits. I have a master's in clinical and translational science, but I am hoping to gain more knowledge into the computer science aspect. So
yeah, no, absolutely. So I would say definitely. So the transformer class is one that is definitely open, and is available for people to register for. Graduate students, postdocs also have audited the class, and also have faculty that will come in. So that's a data science master's class that is available for others to register for. And also, you may not need this one, but we're going to be opening up our programming classes more broadly as well. So we have an AI assisted programming for non-programmers, and we have AI assisted programming for programmers. And that's a course that Sharo, Ray, and I, right, are going to be teaching in the fall. We are looking into opening up some of the other courses a little bit more broadly. It's a little more difficult because our incoming class is large. We have 55 people that are going to be joining us currently in the fall, and that's kind of maxes up our classroom space. And most of our other classes are like, we teach them once a semester, once a year, and so they're full because 55 students, and it just fills the class. So it's difficult for us to open up opportunities for those other classes. And are we able to accept new applicants? You mean people who are at Vanderbilt who want to take the class? Or
I'm sorry. I'm sorry. I just, I should just ask the question, I guess. Oh, well, I just was in the application appears to still be open for fall, but I wasn't sure if it's still open or not. It sounds like the classes are pretty full at this point.
Yeah, exactly. So we've had people accept. So, I would never say never, but we did have, 56 that accepted in our first round of, so we have rolling acceptances, but we had 56 people who accepted in the first round, which leaves no space for others. But, if you have a bunch of people who say, nah, I'm going to go someplace else, which does happen even after they pay their deposits, then that does create additional opportunities as well. So, if you're interested, I'd say go ahead and put in an application. And then, if it doesn't work out, then of course there's the following year as well.
Sure.
Yeah.
Okay.
Yeah.
Thanks.
But weird things happen all the time. Certainly during COVID, we had people who could not come because there was no embassy for them to apply to, and then they just had to, hold off. I'm certainly hoping that will not be the case this time.
Thanks so much. I'm gonna have to sign up. I really appreciate it. I really appreciate the class participation and everything. It's really, really great.
No, thank you, and thank you for your interest in interaction as well. That makes a huge difference. It really does.
And I guess how do you are those online as well, like the two classes you mentioned, or
they are not?
Okay.
Vanderbilt is very particular. If we have an online course, then it can be online, right? Well, it's kind of in its name. But if you have an in-person course, they do not want to have it equally available online on a regular ongoing basis because they are very committed to in-person instruction. So it really is in person.
So both of those, the transformers and the AI assisted for non-programmers.
Yes.
Okay.
Going to be in person. We will be looking into doing additional workshops and opening additional classes. We're still planning that out. We recently got support for an initiative that will be playing a large part in. But those will likely not be full courses. It will be more workshops like this and not as intensive as this.
In the online computer science courses, are those, could you sign up for like a portion of those, or you have to take the whole?
I don't know. I suspect that you'd have to be in a degree seeking program to take this. But I would definitely reach out to ask. The coordinator, the director for that online master's program is actually one of our data scientists as well, on our team. So Professor Dana Zhang, Zhang, is the director of that online CS program.
Thank you.
You're welcome. Liam, did you have a question? And good to
Hey,
see you.
hey, just a question. I just kind of wanted to drop in and say hi. I wasn't able to attend the live this year, but I took the class last year for everyone else, and it was really like transformative for me. So it was fun to see everybody's reactions to it this year. I'm actually on a semester off right now. I've been building products with AI, and that thing I talked to you about before, Jesse, which is the social media caption app, is actually on the App Store now. And yesterday we actually got mentioned by one of the most popular AI newsletters. It was really cool to see. So getting some downloads and stuff.
Which one did you get mentioned by?
Ben's Bites. We were on the top of their listing for AI stuff.
I love it. And what is the name of your app?
Just caption it, all one word. So yeah, it's been super fun to see and build. I mean, it's been way harder than I thought, but all the stuff that I learned that first summer, I've been using like LangChain and all this, so it's been great.
Fantastic. Oh, I'm thrilled to hear that. That is great. I can't wait to get it. I'm gonna download it immediately.
Yeah, just try it out. Let me know what you think. We're working on improving it. And I'm building a bunch of other stuff as well. So it's been fun. It's a great time to be in AI.
Oh, absolutely. Yeah, that's right. Yeah. I hope you're strapped in, because it's gonna even just get faster.
Yeah, it could be a little overwhelming at times, I would just say.
Yeah, absolutely.
With how much is going on.
Yeah, no, it's keeping track of everything is a job in and of itself.
Awesome. I'm looking forward to catching up on the videos, and then probably see you in the fall.
Fantastic. Yeah, and and I'm going to read the Ben's Bites, and I'm going to go and download that app. Congratulations on getting it in the App Store. That is not an easy thing to do, so congratulations.
Thank you. Yeah, figuring out the concurrent users and all that's it's a lot of different problems to solve, but we're doing it. And then I think the newsletter one, it wasn't today's, it was yesterday's.
Okay.
But yeah, cool.
Fantastic.
I'll see
That's
you.
great.
See you later. Thanks
See you.
so much.
Take care. All right. Any questions from other folks? All right. Well, folks, then, if there are no other questions, I'm going to go ahead and call the 2023 AI Summer to a close. Yay! All right. Sharo, Miranda, I will see you a little bit later. Sure, Miranda, I'll be seeing you in just a little bit, right? Because we're going to talk to the next steps, folks.
Right.
Fantastic. Then we'll take a little bit of a break before we get back together again for that.
Perfect. See ya.
Goodbye.